Okay, on the previous videos we saw ways to find limits analytically of what you might call normal functions. Our first step was to substitute, and if substitution gave us a real number result, that was the answer. We always try substitution first. If substitution gave us 0 over 0, then we had different things that we tried, because as a limit, 0 over 0 is indeterminate. As a limit, 0 over 0 tells you nothing other than to try something else. So those were kind of what we call like normal problems. What we're going to move to next are piecewise defined functions. And so here we're going to have a little algebra review first of just working with piecewise defined functions. So here we have a piecewise defined function. F of x equals 2x plus 5 if x is less than -1, equal to 3 if x is equal to -1, and x plus 2 if x is greater than 1. The parts after the if, those are called the restrictions. And they tell you when to use each rule. The 2x plus 5, the 3, and the x plus 2, those are our rules. Yeah, it's not quite legible, so we'll use some whiteout tape. And if you haven't already noticed, I use lots of whiteout tape. And that's just something you'll have to get used to. So again, a little algebra review, how to work with these things. Now, beating this to death, I want to find f of 3. Now, one thing you want to remember, since these are functions, one number goes in, one number comes out. You never get two answers when you're evaluating a function. So f of 3, x values go in. So that's telling me that x equals 3. Then I go and compare that to my restrictions, and I see which restriction is true. X is equal to 3, so x greater than -1 is true. And so that tells us that we should use the rule x plus 2. And so this is going to become 3 plus 2, or 5. Now, if this were a test question, which it won't be because this is just algebra, but if it were a test question, all I would be expecting to see is 5. Everything else is thought process. Same idea here. X's go in, so my x value is -4. Then I go and look at my restrictions. And when I look at my restrictions, x less than -1 is true. So I should use 2x plus 5. So f of -4 is 2 times -4 plus 5, or -3. And then finally, there's my x value. So x is equal to -1. And so very obviously, so x equal to -1 is true. And so we use 3, which means that f of -1 is 3. So there was just a quick review how we pick which branch of the function to use each time. Now, graphing these guys, and we're just going to go the old-fashioned way of graphing. We're just going to make tables of values and graph each part. And since there are 3 branches to this function, 3 rules, we're going to make 3 tables of values. So I'm going to make a table for the 2x plus 5. And so here we should use x values such that x is less than -1. And so x, y, and that's going to be y. Well, let me put it, it's not a y. Let's just put here 2x plus 5. And I'm going to do -3, -2, -1. Well, -1 is not less than -1, so I shouldn't be using it. That's why I have little asterisks. And that little asterisk will mean graph with open circle. Because I shouldn't be using -1. I should be using things only less than -1. but I want an absolutely complete graph. And so if I wanted an absolutely complete graph and I was trying to not use -1, then I should use something like -1.00000001. That would be really inconvenient. So I'll use -1, and just remember to graph -1 with an open circle, which will mean the graph will come right up to that point, but not include that point. So let's plug in here. If I plug in -3, that's going to give me -1. If I plug in 2, that's going to give me 1. And if I plug in -1, what? I will get 3. And so let's go and graph this up here. So I think I'll have room for it up here. So 2, 3, and we'll graph this in pink. How about that? Graphed in pink. So I'm going to have -3, -1, -2, 1, and then 1, 2, 3. -2, 1, and 1, 3 with an open circle, and then the graph would look something like that. So there's the first branch. I'm going to skip to the next branch, or I'm going to skip to the last branch. So table 4, x plus 2, and here we're going to use x values such that x is greater than -1. And I'm going to do the same thing. I'm going to pick -1 again, but I really shouldn't. But I'll pick it for completeness sake, and I'll be sure to graph that with an open circle. And then I'll pick 0 and 1. And so if I plug -1 in there, I'm going to get 1. If I plug 0 in there, I'm going to get 2. If I plug 1 in there, I'm going to get 3. And let's graph this in yellow. So -1, 1, open circle, right about there. 0, 2, right about there. And 1, 3, right about there. And so there's that branch. Then the last part we have to graph is that middle branch. And so the graph for f of x equals 3, if x equals -1, tells us that we have the point -1, 3. X coordinates go in, y coordinates come out. And so f of x equals 3, that 3 is the y coordinate, if we were to put in x. And so how about graphing that in green? So 1, -3, I'm just going to emphasize this guy a little bit. So there was the open circle at 1, -3. And now I have the point -1, 3, which I'll go ahead and fill in green. And so that dot actually gets filled in. And if we were doing this normally, everything would be in blue. But there's my graph. And in the very end, I end up filling in that open circle at the point 1, -3. So there is my piecewise graph of my piecewise defined function. Okay, so there's some basics of algebra and piecewise defined functions. Next, we will go on to finding limits involving piecewise defined functions, and we'll do that in the next video.